Hello friends, today we will understand one of the most important machines in electrical engineering, the transformer, its construction, working principle, types and real-world applications. The transformer is basically a voltage control device that is used widely in the distribution and transmission of AC power. It is commonly used to increase or decrease the supply voltage without changing the frequency. In a step-up transformer, the output voltage is increased, and in a step-down transformer, the output voltage is decreased. The step-up transformer will decrease the output current and the step-down transformer will increase the output current to keep the input and output power of the system equal. The major parts of the transformers are core, windings and insulation agents. The core acts as a support to the winding in the transformer. It is made up of a laminated soft iron in order to reduce the losses in the transformer. The winding is wound on the core. The factors such as operating voltage, current, power decides the core composition. Windings are the set of copper wires wound on the transformer core. There are mainly two types of windings, primary and secondary windings. Primary winding is the set of turns of windings to which the supply current is fed, whereas secondary winding is the set of turns of winding from which output is taken. The primary and secondary windings are insulated from each other using insulating agents. Insulation agent is necessary for transformer to separate windings from each other and to avoid short circuit. This facilitates mutual induction. Insulation agents have an influence on the durability and stability of a transformer. There are several insulation mediums used in the transformers, such as insulating oil, insulating tape, or insulating paper. The transformer works on the principle of Faraday's laws of electromagnetic induction and mutual induction. There are usually two coils, primary coil and secondary coil on the transformer core. The core laminations are joined in the form of strips. The two coils have high mutual inductance. When an alternating current passes through the primary coil, it creates a varying magnetic flux, and as per Faraday's laws of electromagnetic induction, this change in magnetic flux induces an EMF in the secondary coil, which is linked to the core having a primary coil. That means we can say that transformer transfer electrical energy from one circuit to another. It transfer electric power through electromagnetic induction. It transfer electric power without changing the frequency. Two circuits, that means primary and secondary coils, are linked with mutual induction. Now we will see the different types of the transformer. Transformers can be classified based on the various aspects. Based on the construction, transformers may be classified into two types. First is core type transformer and second is shell type transformer. In core type transformers, the windings are wrapped around the core. The primary and secondary windings are wound around the two different limbs of the core. The core has excellent magnetic properties and maximum flux linkage between primary and secondary winding. In shell type transformers, the core surrounds the transformer winding. The primary and secondary windings are wound around the central limb of the core. Such transformers used double magnetic circuits and are suitable for high voltage, low current applications due to poor ventilation. Based on the transformation ratio, transformer can be classified into two types. First is step-up transformer and second is a step-down transformer. A step-up transformer is a type of transformer that increases the voltage in the secondary. It has more turns in the secondary winding than in the primary winding, which leads to an increase in voltage. A step-down transformer is a type of transformer that reduces the voltage in the secondary. It has fewer turns in the secondary winding compared to the primary winding, which leads to decrease in the voltage. Based on the applications, the transformers can be classified as power transformer, distribution transformer, instrument transformer, or auto transformer. A power transformer converts low voltage high current electricity to high voltage low current electricity. They are usually employed at generating stations and transmission stations. Distribution transformers convert high grid voltage to lower voltage for end users and form the final phase in the power distribution system. They are either single phase or three phase transformers and are available in various sizes to serve the various capacities. Instrument transformers are specialized high accuracy transformers designed to step down high voltage and currents to save standardized and manageable levels. They enable the safe operation of meters, protective relays, and control devices. Instrument transformers are further divided into two types. First is current transformer and second is potential transformer. Current transformer steps down the high primary current to a lower secondary current, while potential transformer steps down high voltage to a low standard secondary voltage. An autotransformer is a transformer with a single winding that acts as both primary and secondary winding. Due to the single winding configuration, it makes possible power transmission through electrical and magnetic means. They are widely used in applications that need precise voltage control, such as laboratories and test benches. Based on the cooling methods used in the transformers, it can be classified as dry type transformer and oil immersed transformer. A dry type transformer is a type of transformer that uses air or solid insulation instead of liquid as a cooling medium. An oil immersed transformer, also known as oil filled transformer or liquid filled transformer, is a type of transformer that uses oil as both a cooling and insulating medium. Based on the type of supply, transformers are classified as single phase and three phase transformers. A single phase transformer is a type of transformer designed to work with a single phase AC power supply, while a three phase transformer is designed to work with a three phase AC power supply. So friends, these are the different types of transformers. If you learned something new today, then like the video, share with your friends and subscribe to the channel. And also press the bell icon to get the notification of all upcoming videos. Till time, keep learning, keep growing. Thank you.